topic 4, which is on logic, which is basically what we just did there. It's just being able to communicate with the computer decision-making, relationals, and the and or not structures. So that's a lot of what we have been thinking about, as well as logical indexing, which is what the first quicker question was on how you can set up a condition, which will give you an array of 1s and 0s. And then you can use that logical indexing array. So I have an X array. I'm using logical indexing, and then I'm setting that logical indexing array to Y, and then I'm plugging Y back into the array to just get the values that are associated with those 1s and 0s. So that's what you're going to be doing on Lab 4 if you haven't done it yet. I don't want you to use the fine command. I want you to use logical indexing so you can get practice with it. I also don't want you to be using loops or if statements, which is what we're going to be talking about today, because you're doing that in Lab 5. So in Lab 4, you're supposed to do it with just logical indexing, and then in Lab 5, we're going to redo the lab with loops and if statements. And so I had a couple tips from that I kind of pick up on as we go throughout the last week's lab. So these are just common error messages. So I have 2 arrays A and B defined that are 3 elements long, and then I'm multiplying those 2 arrays by 2. So that's not allowed, right? Because they're not the proper matrix dimensions, because it's trying to do matrix multiplication where it does the first row by the first column of the next one. So we always, except for when we do linear algebra, are going to be doing element by element multiplication. So if you see that error, it's probably because you forgot a dot. But you also see a similar error if you have the dot, but your 2 matrices are different sizes. So here I have a 3 and a 4 size array. So if you're trying to do element by element multiplication, it's not going to work because there's an extra element that doesn't have anything to be multiplied by. So those are the 2 different error messages you might see. The last tip I have for you is to remember to type clear all or clear or CLC and close all at the top of every file that you write. It will reduce a lot of error messages that you end up seeing. So particularly make sure you do it on the, we already have that in between the script when it's running your quiz files. It already does that. And so if you're running it, you might think that it's working, but it just has a local workspace variable in it. So again, make sure you're doing that. You guys have any questions about anything on topic 4? Okay, so what we're going to do is we're going to go through, and I'm actually going to do all of this in the M file. It's easier than switching back and forth for the most part. So I'm going to write my notes in the M file. So what we're going to do today is there's 3 structures that we're going to learn, and one of them we've already talked about in topic 4, which is if-else statements, but we haven't really used them. I just introduced the structure of them. You did a little bit of it in the pre-lab. So we're going to do a lot more examples of those. We're going to talk about for loops, and we're going to talk about while loops. And I have some entertainment for you, mid this. Maybe we'll do it after the for loops, or remind me if I forget. So let's talk about, that sounds so weird, some entertainment. Like no one even knows what I just said, right? But, oh well. This is not that different than whatever else I'm saying. So an if-else statement. Let's just do a couple examples of an if-else statement. So an if-else statement is a way to check a condition, and it's typically used to check a single condition on a single element. So like of an array, for example. So let's say I created a user prompt where I was trying to teach kids how to do algebra. Common thing that we're all doing these days. So I'm going to say 2 plus 3, and I want the user to tell me what 2 plus 3 is, and then I want to give back a response to the user on whether or not they responded with the correct answer. So I could create an if statement where I take the output from that prompted input and I check to see if it's right. So what is the correct answer? It's 5. So what condition could I put next to the if statement that would check to see if it's right. Check to see if x equals 5. So the relational condition for an equals is a double equals. A single equal sign is a definition. And then inside the if and else statement, I can put any commands that I would like to be executed if that condition is true. So for example, for this simple example, maybe I want to just say correct, good job, right? Or what other options could I do? So let's say I wanted to help the user out. Let's say that they guessed an answer that was too low. So let's say they picked something less than 5. Then I could have a display statement that says too low. And then I could do another condition that's too high. And then I'm going to close my end. Yeah, there's probably some very large limit, but yeah, basically as many as you want. Remember, an if and an else if means that there's a condition here, and I showed you this last lecture, that they're checked sequentially. So if this is true, then this runs, and I think it skips the rest. Is that true? Because I keep forgetting to look. I think it's true. Otherwise, if it's false, it will check the next one, and if this one is also false, it'll check the next one. Where if you have an else statement, if the user puts in anything else, like maybe the user puts in not a number or a string or something like that, you could have another display statement that is any other condition. So let's just run this and see what happens. So I'm going to go into the command window and show you what's prompted here. So I ran the code, and then I'm getting the prompt, 2 + 3 equals, and then I put in 5, and it just displays the one that met that condition. I can run it again, and I can try 4, and I get the statement too low, and then I run it again, and I put 7, and I get too high. This is not going to work, actually, if I put in a string, because it's going to convert it to a number. So the else statement probably won't work, because it's going to convert that data type into a number. But you get the idea of how the if-else statement is structured. Because it's using a relational condition here, well, actually, no, that's not what it is. So x is on, he asked why it's converting that string to a number. Unless I put an s here to tell it that the prompt was going to be a string, it's going to automatically convert whatever's inputted into a numeric. So every character has a number associated with it in order to store it into the computer, and so it'll just convert it to that. Okay. So you can also nest if statements. So let me show you that. So I'm going to copy this code that I just wrote, and I'm going to reduce it to 2 nested if statements. So let me give you an example of when you might want to have a nested if statement. So let's say that we wanted to first make sure that the person entered in a number. So this could be set up through the input prompt, but it could also be set up through this check here. So there's a function that's called isNumeric, and I'll go over to the command window and show you how it works. Can you guys see everything that I'm putting up here okay? Like the contrast and the size of the font is okay? So isNumeric is just a simple check that checks if the number is a value. So if I put in a 5, it's true. If I put in a string, it's false. So you could have a check, something like that first. And if it's numeric and it's true, it'll move on to the next if statement. And then I could just have the check that we did before that checks that it's right. And so sometimes you want, a lot of times we do And I'm just going to do a smart indent here to fix the indents of my nested if statement. You can just highlight the code, right-click, and then go to smart indent. On a Mac, it's also shorthand the command I, but it's different on a PC. And so that's kind of how a nested if statement. We often nest if statements around our logic in order to just make sure that the intention of the code is being done by the user. So sometimes we're asking the user to input something into a function, and we want to make sure that they're doing it properly. Like they're either giving us enough inputs, it's the right type of input. So we often have these if statements that just nest around our entire code to check on that. Okay, so let's talk about for loops now. So that's how if statements, and we usually use if statements in conjunction with for loops or while loops. Now, the reason for that is I just asked the user to tell me what 2 plus 3 was, right? And if they don't get it right, you want to ask them again, right? And so that's where this loop is coming in. It's where you want to start repeating, repeating commands until some condition is met. So a for loop is the first type of loop that you're going to explore in this topic. And a for loop runs a set of commands a predetermined amount of times. So there is a structure to the for loop. The structure is that you open a for loop with the word for and you close it with the end command. And although I always show the structure and the book shows the structure, I find that most people don't understand it until they see it in an example. So typically what we do is we need to tell the computer to somehow repeat all the commands between for and end some number of times. So let's say that I'm just going to put a display statement in there, and I want it to display whatever is in the display statement 10 times. I want it to display 10 times. With the for loop, the syntax for that is you create a variable. You can use any variable you want, but we often use I. And you create an array. And the array tells it how many times to run the loop. So right now I have an array that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for every value in the I array, it's going to run the loop. Yes?
What happens if you did like 1:2:10? Would it only do 5?
It would only do 5. Yeah, so it only runs the loop for every element that's in the array. And I think that this would make so much more sense if you could just say, instead of this, if you could just say n equals 10, and that means run this loop 10 times. I feel like that would make so much more sense, but that's not the syntax. The syntax is you put in an array, and it runs it for the number of elements in that array. Did you have another question?
Does that affect your imaginary number I?
Yes, it overwrites the imaginary number I. That's right. That's okay, we don't use it ever in this class. So, but you could use N, you could use K, you could use whatever letter you want, but I'm a modeler, I'm a fluid dynamics modeler. We always do every loop. We start at I for our first loop, our next loop is J, our next loop is K. We use N for time, so I just use I as my first index. I always use it. That's just the notation. That's what modelers do. So you can see I ran the code and it printed hi 10 times. So that's all it does. And if I changed this to 5 and ran it, it would print it 5 times. And then let's do a different step size. Let's just do every 1, 3, 5, all the way up to 9. Also is going to run it 5 times because it's just running it for every I. Another thing that's really useful when you start writing loops is inside your loop, you can print your index. So just type your index and don't suppress it. And that way you can see every time you run the loop, I starts out as 1, I printed high. Then I is 3, I printed high. Then I is 5, and I printed high. And so you can kind of see what it's doing at every loop. But all it's doing is repeating whatever is inside the for loop for every element of I. Okay, so that's the syntax of the for loop. Okay, so let's do a couple of examples of what you would actually use for loop for. Okay, so let's just look at how you could define arrays using a for loop. So I'm going to show you 3 methods for defining arrays, and they're all going to be doing the same thing in 3 different ways. So the first way is the way that we've already been using to define arrays, which is using vectorized notation. So I'm going to create an X array, and I want you to see how many elements they are, so I'm actually going to type out every element, and I'm just going to have 5 elements. So I'm going to just do every quarter pi. So we have 5 elements: 0, pi over 4, pi over 2, 3 pi over 4, pi. So that's my X array, and I want to create an F array based off of that X array, and it equals sign of each X element times each X element. That's just what the definition of the function is. So using vectorized notation, you create your vector, and then you use vector notation. So you're applying a function to a vector. You're dot multiplying to do element by element multiplication of the vector. And that does all that arithmetic at once. So all 5 of these elements are getting multiplied at the same time. So that's the method that we've already been doing. And it's the best method. It's the fastest method and the best method, but it's not always possible. So some things are too complicated to do vectorized. So the next option is to do it in a loop. So you create a for loop wrapper, and you're going to create an index that's going to match up with the elements of the array. So we know that we have 5 elements, so I'm going to hard code this in, starting at 1, step size of 1 up to 5, so I can do every element one at a time. And then, honestly, this is probably one of the most confusing things is this indexing to people, but we're going to index this function with the index of the loop. So instead of just putting sign of x and putting the whole vector in, we're going to do sign of xi, meaning that when I is 1, it's going to define the x of one element to the sign. So it's going to do each one at a time. So these 2 things are exactly the same. The only difference is this does all 5 calculations at once. This one is going to step through for I equals 1, it's going to define f of 1. For I equals 2, it's going to define f of 2. For I equals 3, it's going to define f of 3. So it's going to do each calculation one at a time. So this is going to take 5 times longer than this. But sometimes you have to do that. The problem with doing it just like this is that what MATLAB is doing, every time it's filling in the next element of the F array, it's actually creating a new array, and it's finding memory for it. MATLAB is the only software program, only programming language that I know of that does not require you to pre-allocate your variables. So it allows you to do this, but it's very slow. So if you do this without pre-allocating, it can take like 10 times longer to run your code. So what you want to do is method 3. And this is in the book, it's described, and you're also going to do this in your pre-lab, is you're going to, before you fill F, you're going to set an array up, fill it with zeros, and make it the right size. So the way I always do it is I just use the zeros function, which I showed you in topic 2, and then inside the zeros function you put the size you would like the array to be, and since we already know that f is going to be the same size as x, we can just use the size function. So you do f equals 0 size of x, it will create an array that's 5 big of all zeros. So I'll run this with a pause underneath it. So it's just going to create this, and then you'll see as we continue through the code, I'll run it and I'll do a pause after every time an element is defined. So I'm going to pause here after the F, and then I'm going to pause each time the new element is defined in the for loop. So here's my first pre-allocated zeros. I think the first element is 0. The second element is 0.55. The third element gets defined, the fourth, and then finally the fifth. So it filled it in one at a time. So let's look at what's different between that and this without pre-allocating. So again, I'm going to unsuppress, I'm going to pause, and I'm going to clear all at the top because I just pre-allocated that. Oh, I have to get rid of this too. Okay. Yes. Yeah, thank you. I don't want the F, because then it would know what it was. Okay. So F starts off as 0. So it found memory to hold an array with one element. Now it's going to go back, search through memory, and find another spot that now has 2 elements, now 3. And so this array is growing. And in fact, when you do it in MATLAB, it actually will give you an error message that says, like, I think it's under the F, the variable f appears to change size on every loop iteration. So it'll give you an error message and actually ask you to pre-allocate because it is so much slower to do it that way. So if this makes no sense to you, the pre-allocation, take some time to read about it, or just always pre-allocate with zeros before you define an array. So that's one example of how you can use these loops. Next, I'm going to show you how to do a calculation. And again, I'm going to show you 2 methods because we've already done calculations using vectorized notation. So let's say I have an array P and I have an array Q. They're the same size, and I just want to multiply the 2 by each other. So if I want to do element by element multiplication, I do P dot multiply Q. So that's the method 1, that's the vectorized notation. Okay, with a for loop, we can just do each multiplication one at a time. So I'm going to set up my index I, and I'm going to write this in general so you can see how you can set up your loops to be general. So I want to go from 1 to the end of the P and Q array. So what can I put here to, in general, say how long I need to do this calculation? So size of Q would work, but that's going to give you the 1 by length. So the best way to do it is actually length of Q. And since Q and P are the same, you can just choose one. And that will start at 1, then go to 2, and all the way up to the total size of the array. I'm going to index M to define each element one at a time. And then I'm going to index P, and I'm going to index Q. And you'll notice when I do this inside of a loop, I do not need to have dots because I'm just always multiplying 2 numbers by each other. And I always have to index to tell it which element to pull from. So these 2 things do the same thing. Can anyone tell me anything that I forgot? Yeah, you need to pre-allocate M. So before you start the loop, you just want to set up an M array that is the same size as P or Q. So hopefully that gives you a little bit of an idea of how loops work. And now I have a little example, and you're going to do a very similar example in your pre-lab. Sure. I'm gonna put it back on. I just need to get this back up. Everything is so large on my screen that I have a little bit of trouble getting everything to show. Okay. So this is an example that I often use to kind of show the strength of loops. And I call it I call it condensing code with loops. It'll definitely be on the exam, probably both exams, and I just do it all the time. So the idea is that I have a long set of code that has a lot of repetition in it. There's a lot of things that I repeated, but just have a slight change in them. So the strength of loops is that anytime you start repeating code, like you're copying and pasting code, you want to think of a way of putting it into a loop and indexing it so it'll do it automatically. So this is something I've done in past semesters, but I've never thought about showing you it at the very beginning. So you guys all know how to plot. So all this code that I have here does is it creates a subplot. So let me show you what this plot looks like. Okay, so it's a 2D plot. So I just define an X and a Y, and I mesh grid it. And then I have a Z that's just like, makes a circle, basically. And the first plot, the circle is centered at 1. The second plot, the circle is centered at 2. And the third plot, it's circled at 3, or it's centered at 3. You'll also notice that my titles are 1, 2, and 3. And if you go a little bit further into the code, you can see that a lot of things, there's like a pattern. So here I have subplot 1. I have it centered at 1. I have Z1, and then I have plot 1. And then I just copy and pasted it, and I just changed the 1 to 2, the 1 to 2, the 1 to 2, the 1 to 2. So there's like a lot of repeating of the same commands, just changing one thing. So I want to show you how you can rewrite this code so that it has a loop that is running through all of that repetition. So what I'm going to do is I'm going to copy and paste one subplot and the definition of the variable. I guess I don't even need to define the variable, so we'll just copy and paste just the subplot. Okay, so it's just 4 lines of code that are repeated. And I'm going to open up a new figure that I'm going to, so that I can compare the two. So my original one is going to go into figure 10, and this condensed code I'm going to put into figure 11. And then I'm going to wrap a for loop around it, and I'm going to create an I index. And what should my, my array be for I in order to get this to work? 1 to 3. So I just have it, I need it to run 3 times, so I need to start at 1, end at 3. And then everywhere where I was changing that 1, 2, and 3, I'm going to replace it with an I, an I, an I. I actually can just get rid of this. It'll just overwrite it. And then an I here. So here I'm going to use the num to string, because I need to convert the I into a string to include it into the plot. So I changed the I at the subplot, the I in the function. I got rid of this repeated number in the variable definition, and then I updated the title. So if I run this, I have figure 10 and figure 11. And they're the same thing, but I condensed the code down by 3. And you could imagine that that could be much more powerful in a lot of other cases. And so that kind of gives you another example of like how useful loops can be. And you're going to notice that a lot of times in this class for like future labs, you're going to be repeating by copy and pasting a lot of things. And so I always want you to think about, can I condense it by putting it into a loop? Is there any questions about that? Okay. Now, we're going to talk about a for loop. Now, a while loop. So a for loop, remember, it runs a predetermined amount of times based off of the array on the right of 4. A while loop runs the code inside the loop until a condition is met. So you use a while loop when you don't know exactly how many times you need to repeat a command, but you know a condition that needs to be met until you stop. So a great example is the counting example that we just did. So I did that input prompt where I did 2 plus 3 equals, I set it equal to x, and I don't know what the user is going to put. I don't know if they know what 2 plus 3 is, right? So depending on how many chances it takes them to get the right answer, I'm going to need to keep asking them, right? So I don't know how many times to ask them. So you're going to wrap it in a while loop. And then what could be a condition on x to run the loop? If x doesn't equal 5, you need to keep running the loop. You need to keep giving this person a chance. So x doesn't equal 5 is the condition. If that condition is true, the loop runs. So it's sometimes people think of it, it's more intuitive to think of the false condition that makes it stop running, but the way the while loop works is the condition is true, and as long as it's true, the loop keeps running. All right, let me run this. So this is the code. Let's run it and see how it works, okay? So I started it, got an error. It says undefined function or variable x. Does anyone know what might be wrong with this, the way it is currently? Yeah, it's using an x right away, but there's no x defined because we defined it inside. So what could we do? Yes, and this is also sometimes called pre-allocating. So we need to have a condition in the while loop, and so you always need to set the value before the loop starts. So this is one option, is just ask the prompt again. This is not always possible depending on what you're doing. Another option is just setting it to something that makes the loop run. So if you set it to 0, the loop is satisfied, that condition is satisfied, so it will start the loop. You can do either of these two options. You wouldn't want to put 5 because then it wouldn't run because the condition isn't true, but anything else would be fine. So let's see if it works. Okay, so it ran, it did the prompt. I'm going to try 4. It's not liking that. It's not liking. See how many times you could do this forever. And then I put 5, and then it stops. So that's the way a while loop works. Do you guys have any questions about that? Yes, so you could put an if statement inside the while loop or nested around it. There's lots of ways to then, based off of the response, give a specialized response. Sometimes people say things and I actually don't know who's talking, so I'm just like looking around. Who said that? Okay, yeah. Does that make sense? Okay. Okay, the next thing I want to show you with loops is unfortunately, for loops are not actually ever needed if a while loop is used. While loops can always replace for loops. So I'm going to show you how you can replace, I'll just copy and paste it down here so you can see how we did it. This one here. So you can always replace for loops with while loops. So I need the x. This is like giving me a headache. I'm sure it's giving you a headache. I'm scrolling this. Here's my x. So I'm going to rewrite this for loop with a while loop. So I'm going to take this and I'm going to wrap it in a while loop. The difference is that a while loop needs a condition, not an array. So the condition is that you want to keep defining f values as long as I is less than or equal to what? 5, that's right. And as long as that is true, f will continue to be defined. You can pre-allocate just as you did before. And then you need to start I at something, right? So you're going to start I at 1. I is now 1. 1 is less than or equal to 5. That's true. So f of 1 will be defined. And then it's going to check it again. So in order for this to actually work, the trick is with while loops is that you have to advance the I inside the loop. So I starts at 1. 1 is less than or equal to 5. So it goes into the loop. You define 1. Now 1 equals 1 plus 1, which is 2, and it checks again. 2 is less than or equal to 5. Now it's going to define the second element of f. Then I is now going to be 3. It's going to check again. It's just going to keep doing that. And it's the exact same thing as the for loop. And so I encourage you, if this makes more sense, the while loop, you can exclusively use while loops. Because some people, the advancement of the counter or this I is just more intuitive and it just makes more sense. So you can always do that. Any questions about this one? Yeah.
For the I is 5, could that also be the size?
Yeah, the length of f. Yeah, length of, yeah. So if you want to do it in general, you can do length of x. And you should. I was just showing this as more of a simple example. Any other questions about the while loop? Okay. Now, in your lab 5, in your lab 5, you're going to do part A, which is the same as lab 4, but with loops. And so you're going to use for loops and if statements for part A. Part B is for you to use a while loop. There's no way, I've tried for years to come up with an assignment that requires you to use both, and I cannot. So you just have 2 different assignments. But part A you've already done, but you're just redoing it without logical indexing. The last thing I want to show you with loops is nested loops. So I showed you a nested if statement, and now I want to show you a nested loop. So do you remember when you did this mesh grid thing and you're like, this is insane, why are we doing this? This is the alternative to doing mesh grid. So with mesh grid, it's a way to create a 2D array, Z1, or I'll just call it Z, using an X and a Y. And that's because it's confusing because you're doing a lot of arithmetic at once. The alternative is to use 2 nested for loops. So for a lot of the classes that you're going to be using, or you're going to be using this in, like 303 and then the modeling classes, they use exclusively loops because vectorization can be confusing. So this is the alternative, to use the loop. So you're going to create a nested for loop, and the for loop is going to have each for loop is going to have its own index. So I is going to be the first for loop, and I'm going to go from 1 to the length of x. I'm going to use j as my second one, and that's going to go from 1 to the length of y. And then instead of doing all of this using vectorized multiplication or powers, I'm just going to index each of these. And this, you don't need the dots here because it works the same. This is going to do the exact same thing, but it defines each element of z, which is a 2D array, one at a time. So it's basically, the way you can think of it is it's going to define the z for x equals 1, y equals 1. And that's for an I of 1 and a j of 1. Then it's going to define z for I equals 1, j equals 2. Then it's going to define the z for I equals 1, j equals 3. And it's just going to go through and do every combination of I and j. And it does the exact same thing as mesh grid. It's not exactly oriented the same because they're stored slightly different, but with like a transpose and stuff, it does give you the same thing. So I can create a contour plot here so you can see what the result of this is. So I'll do contour x, y, z. Oh, gotta get that answer right. And so this is the plot that's created from that function. So there's a lot of cases where it is too confusing or too difficult to do the vectorization and you just want to do the loop. And I think I have you do that in the pre-lab. Yeah.
What is this script can be running in Java Live script? We're also trying to get that you have the double percent for your comments.
Oh, the double percent uses this feature in MATLAB. It's called the publish feature. where you can go here and click publish, and it puts your code into sections and formats it really nicely. And so there's also now, MATLAB has, can you guys just hold on 1 minute? There's also these things called active scripts. So now in scholarly journals, you can not just submit a figure, but you can submit an active script, so that when you're reading the journal, you can actually move around and toggle the figure to look at what the plot looks like. Like you can zoom in on the plot or zoom out on the plot or toggle it around. It's a new feature, actually, 2016 and newer. Any other questions? Okay, well, you're good to go then.